Problem 8. Let's have a look. Nina is playing a game with a square. First, she writes either 1 or -1 on each side of the square. Then, in each corner, she writes the product of the numbers from the two sides that meet in that corner. Okay, so that means that there's a 1 here, there's a 1 here. 1 times 1 is 1, so that the corner that they meet must be this one, which is 1. Okay. What else? Finally, she adds up the 8 numbers she has written so far and writes the sum in the center of the square. Okay, so that's 2. That's a 1 plus 1 plus 1 plus 1 plus 5. And then -1 minus 1 minus 1, that's -3. That's 5 minus 3, that's 2. Okay. In the figure, you can see the result if she writes -1 on one side and 1 on the other 3. How many different numbers can Nina end up with in the center of the square? Okay. Very interesting problem. I like these kind of problems. So it's pretty clear immediately that there's no kind of standard approach that we can use here, because it's not something that we just kind of can turn into equations and use some sort of formula or something like that. So, but what is good is that I can immediately see that in the options, it has to be some number between 5 and 16. So that's good because that's not, 100 or 200. So even if we were to write out all of the different possibilities, we could even do that. Even though I'm not suggesting that we do that because it's probably going to take a long time. Let's see. Let's see what we can do here. So I don't know what you're thinking here, but my thinking with this kind of problem is that I want to just kind of sink my teeth in a little bit and get a feel for what I'm working with. And so I'm just going to go with an example to see maybe that will lead to some sort of insight or some sort of pattern that I can see. So I'm going to keep it simple, and I am going to, up here actually, make another figure here, and I will give it slightly different numbers. Oops, let's do a shift so I can get a straight line. Perfect. I'm a bit of a perfectionist when it comes to this stuff. Oh, one more line, maybe. Hey, there we go. It's not exactly straight, so how can I get it straight? There we are. Okay, that's good enough. So, okay, let me do another example. So 1, -1, and 1 and 1, let's say. Okay, so with using those, the products with here would be 1, -1, that's -1 here, and then -1, 1, that's also -1 here, and then there's 1, 1, that's 1, 1 times 1, that's 1 as well. And so that was just going to give me 1, 2, 3, 4, 5, -1, -2, -3, that's also 2, okay. That is also 2, that's very interesting. I don't know if you can see it already, but I'm sensing something interesting here, because what did we just do? We did a unique configuration, or rather a different figure that we created with different numbers, right? But we ended up with the same sum. Why is that? Well, the only difference between these two is that the -1 in this case is on the bottom side, and this one is on the right side. Okay, what does that mean? Well, what that means is that these two figures are exactly the same. The only difference is that this one is rotated. So if we were to rotate this figure this way, 90 degrees, let's say, 90 degrees, then it would get us this one. Okay, that's interesting. Well, if that's true, then what then must be true too? Well, if you can rotate it once, then you'll have the -1 here. But if you did that once more, you'll have the -1 up here. You'll have the -1 here, and then going back to it, right? How many does that make? Well, that's 1, 2, 3, 4 for each side. So I got one figure that represents a whole group of 4. So I don't need to actually write out all those. From simple symmetry, I can deduce that that's what I'm going to get, and that's all going to result in the same sum in the middle, which is going to be 2. This is interesting. Because if that's the case, then I can very quickly see that's also going to be the case for if I started changing the numbers here. So here's what I'm going to do. I'm thinking that there are some numbers which are going to be the representation for a group where you can do these rotations. So let me start listing those out. Hopefully there's not too many of those. We'll quickly see how many there are if we write those out. So let's see. So I'm gonna try to do this in a systematic way. So up here, I'm gonna make a little figure. I'm not gonna make it too large so that we don't spend too much space for this. Let's connect those here. There we go. And once more here. All right, now let me take that and copy that from over here, and I'll put it right here. Okay, so let's see then. The first one I want to go with, I want to do it in a systematic way. So I'm going to go with 1, 1, 1, and 1. Now I can immediately see that this one is just by itself. There's no other rotation for this one that gets us to a different figure. So this is gonna be a simple one. So the 1, 1, 1, and 1 products go there, and what's going to be that? Well, it's going to be 4 plus 4. That's 8. That's one of them. Okay, hopefully that is visible to you. It wasn't too small. I'm going to make that a little bit larger here. Okay, now let's have another one of these. If I were to copy and paste again, put this one here. What is going to be the next one? All right, so the next one, let's do one of them being negative, which we already have. That's 2, right? So let's do -1, -1 down here, and then 1 and 1. For this one, we already figured out that if we rotate this 90 degrees, we get new figures. So for this one, there's going to be 4 different figures in this group that are going to give you the same number in the middle. That's going to be 2. Okay, so far we have how many different numbers? Can Nina and Evu? So far we're at 2. Okay, what is going to be the next one here? Okay, let's think about this. We've already done one of the numbers being negative. Let's go with 2 numbers being negative. Okay, so let's think about this now. If 2 numbers were negative, how could they be placed on a figure? Well, the one of them, one obviously would be where there's a negative here, and then there's a negative here, and then the rest are positive. Let's do quickly what we would get here. -1 would be resulting in a +1, -1 here, and there's a 1, and then there's a -1 here. There we go. Now, let's add these numbers up together. You got a 1, 2, 3, 4, and you got a -4 -1s. That's going to be 4 minus 4. That's 0. Now let's think about how many different figures are going to go in here. Well, you're going to have, this is one of them. You can rotate that 90 degrees, and then you would have a -1 here and a -1 here. That's 1. And then you can do that again, and you had a -1 here and here. That's 2. Then you can do it again. You have a -1 here, and you're going to have a -1 here. That's 3. And then, of course, this one, which we didn't count, is also one of them. So that's also 4. Okay. That's 4. That takes care of that. What else do we have here? So if we bring... put this one here. And then let's do... What is the other way that we can have negative numbers? Well, they can either be side by side or on the opposite side of each other, right? So let's count that too. There's a -1 here and a -1 here. And then there's a 1 and a 1. And then, of course, if we do this again, it would be -1, -1, and -1, and -1. So that's going to be 2, +2, and then 1, 2, 3, 4, 5, 6 negative. So how much is that? That's 2 minus 6. That's -4. -4. Like this. How many of these are we going to have? Well, this is a special case, right? There's not going to be 4 of these because you can either have -1, -1 like this, or you can have -1, -1 like this, right? So there's only 2 of these. So 2 of those. Okay. So let's continue. And what other ones do we have? Well, we obviously have -1, -1, -1, 3 negative numbers. So let's do that one. -1, -1, and -1. And then we have a positive here. And then let's do that quickly now. That's going to be a 1 and a 1 and a -1 and a -1 here as well. And then what does that make? So that's 1, 2, -1, -1. Let me see if I can do this right. Yeah, so there's a 1, 2, 3. There's a 1, 2, 3, 4, 5. So that's 3 minus 5. That's -2. Okay. So, and how many different ones are we going to have this one? Same principle as before, right? It's basically is just the inverse, the opposite version of this one that we did over here. And so it's going to be 4 of those as well for the 4 sides. Okay, are we missing anything now? What are we missing? Well, we're missing definitely 1, which is the -1, -1 for all 4 sides. Let's do that one. There we go. All right, so that's a -1, -1, -1. And that's a 1, 1, 1, of course, because all the numbers are negative. So that's going to be -4, and then +4, that's also a 0. It turns out the 2 of them are the same. How many of these are going to be? Just 1. And how many of these is just 1 as well? Does that cover everything? Let's think about this. So we got all the 1s here. I'll go the -1s. There's only 1. Pretty simple. Then we got a -1 and the rest 1s. And then we're slowly building up to the opposite of all -1s. So let's see if we counted everything. -1, 4 of those, 2 negatives, 4 of those as well. And there's another way of having negative and negatives, having it opposite to each other. And we found out that there's only 2 of those. Now what's interesting here is that if you have a negative and a negative opposite of each other, you have to have a positive and positive opposite of each other too. So we don't need to count those, in addition. Those are already counted in. And then of course there's 3 negatives, which is going to be the same, 4 rotations. And then there's the all negatives. You know what? I think we're good. How many numbers does that make? Well, we have an 8, and we have a 2, and we have a 0, and we have a -4. Now a -2, and then we have a 0 as well. Well, of course, we got 2 zeros. So that means that if we remove those, the numbers written out, let's see, let's write them from least to most. -2, 0, and 2, and 8 at the end. That is 5, and that is going to be A. There you go. So, yeah, fun problem to solve. What was the key insight on this one was that we figured out that there were a couple of cases that the rest of them were just rotations of that. So that drastically reduced the number of cases that we actually had to test for. It was only 6, and we did it in a systematic way, getting us to 5.